as many of you have asked, this is the JEE Main 2026 most expected paper. So this video covers the numericals, assertion reason type, and the MCQs, which are mostly based on the January attempt. Okay, I highly recommend you to attempt the paper and check for the answers. Or else, if you are unsure about not having much time about attempting the paper, you can check the answers. You can see the full video to know the questions and answers. Okay. So without any further delay, let's get started with the first question. For PCl5 gives PCl3 and Cl2 at 500 Kelvin and 2 atm total pressure. Right? The degree of dissociation alpha is equal to 0.6. Now we have to find the Kp value. They just only gave you the total pressure. Okay, they are asking you to find Kp. Okay, how we go about this question? Let's draw the ICP table. Let's take PCl5 gives PCl3 plus Cl2. Let's take the initial moles of PCl5, that is 1, and this becomes 0 and 0. What they have given is the degree of dissociation alpha, that is 0.6. Okay, so which means dissociation, how much that is formed, that is 0.6. So 0.6, this is also 0.6, which will become 1 minus 0.6, that is 0.4. Right? Now, they have given the total pressure, that is 2 atm. Right? So the total moles here, that is 0.6 plus 0.6, 1.2 plus 0.4, that is 1.6 moles. Okay. Now, let's do this. The pressure of PCl5, which is equal to 0.4 out of 1.6, right? And into 2, which will give you the pressure, because we can use this mole fraction formula, right? So which will give you 0.50 atm. Similarly, if you find for PCl3 or Cl2, which will be equal, that is 0.6 by 1.6 into total pressure, that is 0.75. Now write the Kp expression. P of PCl3 into partial pressure of Cl2 by partial pressure of PCl5, which is 0.75 into 0.75 divided by 0.50, which will comes out to be 1.12. Let's check out the option. Yes, 1.12. So you should know what does it mean, right? What degree of dissociation is mean. Okay, let's move on to the next one. They have given the KSP of Ag plus and the AgI. Log 8.5 is this, and the temperature is also given. What they are asking? Standard electrode potential of AgI2, Ag and I minus. Okay, so how we can go about this question? Let's write a formula first. E naught of AgI to Ag, that is equal to E cell, which is Ag plus to Ag. E cell is equal to E naught cell of this one plus 0.0591 by how many electrons? 1 electron into log KSP. Right? So how to find log KSP then? KSP value is given as 8.5. 8.5 log is 0.9. So I'm substituting the value. This value is 0.799 plus 0.591. Log 8.5 is given as 0.929. But here we have 10 to the power minus 17 too. So I'm writing it in the way equal to 0.799 plus 0.0591 into this. I'm writing it as 0.9, that is the log of that, right? So 0.929 minus 17, because I had there, that is log 8.5 into 10 to the power minus 17. So that will come in the front. Remaining, I'll have log 8.5, which is 0.929. So totally, how I can write it? 929 minus 17, right? So minus 17, that will become minus 16.071, right? By substituting all those values, I'll be ended up with minus 0.151. Okay, it is a bit different question. Usually, we won't be linking the ionic equilibrium with electrochemistry, but it's a combination of that. Okay, solubility product and the electrochemistry part. Then the next one, N2 Haber's process is given, delta H naught, delta S naught, delta Cp is given. What is the value of delta G naught? Okay, so delta H naught at 500 Kelvin, delta H naught at 500 Kelvin, how we can find it out? Which is delta H naught at 298 plus delta Cp and delta T. Right, so let's substitute the values, which is the minus 92,000 kilojoule with 92 kilojoules, so which will become 92,000. So minus 92,000 plus this is minus 20 joules. What is the difference between these two temperature, 500 and 298? Just substitute the values, which will be ended up with minus 96,040. This is delta H naught at 500 degrees Celsius. Now we are going to find delta S value. Delta S naught at 500 Kelvin. So which is again, we have to substitute the delta S naught at 298 plus delta Cp into, what is the formula? Ln T2 by T1, right? So just substitute the values, which is given as minus 198 plus minus 20 into ln 500 by 298, which will be minus 208.36. Now finally we can find out delta G naught value, that is delta H minus T delta S, right? Now we can substitute all those values. The first one I got it as 96,404 minus 500 into minus 208.36. So which I'll get it as plus 8.1 kilojoule. Let's check out the options. It's plus 8.1 kilojoule. So this is a different kind of question. Mostly they didn't ask, but we can expect this question this April attempt. And the next one is pH of 0.1 molar ammonium cyanide at 298 Kelvin. Ka of HCN is given and Kb of ammonia is given. pKa value is also given. So what they are asking is calculate the pH. Okay. So first of all, we have HCN and the combination with ammonia, right? That is what ammonium cyanide is. So that is in salt of weak acid, HCN plus weak base, ammonia. So what is the formula for that? pH is equal to 7 plus 1 by 2 pKa minus pKb. So sometimes, okay, let me finish this calculation part. 7 plus 1 by 2, pKa value is 9.2 minus 4.745, which will comes out to be 7 plus 2.23. So what does it mean? Sometimes from here they can ask you theoretical questions as well. Okay, what does it mean? What does pH mean? Both are weak acid and a weak base. Now it explains about the Ka value of HCl. That is less than the Kb value of ammonia. Right. So which means cyanide Cn minus hydrolyzes more than ammonium ion. Okay. So which will hydrolyze more than the ammonium ion. So which will lead to the solution much more basic. Okay. If there is a pH 7, then we can assume the solution is neutral. That effect will cancel out each other. But here we have pH greater than that, which means the solution becomes basic. Why the solution become basics? In those theoretical type, you can use these reasons. Okay, that's why I picked this question. It may look simple, direct substitution type, but the theory is more important. Then correct increasing order of O-N-O bond angle in these three. NO2 plus, NO2 and NO2 minus. So basically, the more information about this one is the first one, NO2 plus, which that will have two double bonds, right? Two double bonds and there is no lone pair. What is the geometry of this? That is linear, right? Bond angle becomes 180 now. sp to sp hybridization. What about NO2? NO2 that will have one unpaired electron and the hybridization becomes for bent and the angle because of the unpaired electrons it becomes 134 degree. sp2 bent. What about NO2 minus? NO2 will have a lone pair. One lone pair and this is also bent, but the angle is because of the lone pair, right? Here that is unpaired electrons, here we have lone pair, that is 115. So which will lead to the answer NO2 minus, that is less, then comes NO2, then comes NO2 plus, option C. And one more information is that if there is a single unpaired electrons are there in a compound, then that will show less angular repulsion. Unpaired electrons, usually we compare it with bond pair and lone pair, right? So what about unpaired electrons? So the unpaired electrons will show less repulsion. Less repulsion than the lone pair. Okay, so that's an important point. That's why the angle becomes more for NO2 minus. Okay, in the next one, R2-bromobutane is treated separately with three reagents. Okay, NaOH in aqueous 25 degrees Celsius, product P is formed, and sodium methoxide, product Q is formed, silver nitrate, product R is formed. Which statement correctly describes the products P, Q and R? Okay. Here we have the stereochemistry part and the reactions as well. Okay. So first of all, what is this R2-bromobutane? What is the first reaction? Let's take 2-bromobutane. 2-bromobutane. Okay. Now, first reaction which is with NaOH. NaOH that is in strong nucleophile. OH is a strong nucleophile. So which will lead to the formation of SN2, right? SN2 substitution. Always remember one thing, I think in the last video or before video, one comment was there, How to find which nucleophile will lead to SN1 or SN2? Remember, if there is a strong nucleophile, that will lead to attack first, right? So which follows SN2? If the nucleophile is weak, then like lazily, let's say carbocation will form and then I'll go and attack. Okay, remember like that. Right, so here we have SN2 and it happens at low temperature, 25 degrees Celsius only. So which will lead to the formation of inversion, right? Inversion in configuration. So R2-bromobutane substitution, right? Br will become OH now. So it will become butane 2-ol, that is S now. R will become S. So the first product P, that is S2-butanol. Let's check other one also, other two. Sodium ethoxide with ethanol at 80 degrees Celsius. What type of reaction this is? It is also a strong base, a high temperature, which will lead to elimination, right? That is an E2 elimination. So E2 elimination, sites of product will form, that is butene, right? Butene. Then comes AgNO3. Again, this is what the reaction we discussed in that paper. AgNO3, basically remember, Ag is more friendly towards our halogens, Br, I, Cl, like that. If I'm having NO3 with that, it definitely doesn't want to be with NO3, it wants Br from the compound. So what it will do? It will follow SN1. Okay, it will follow SN1. So SN1 means what is a product? What type of product will be formed? Racemic mixtures, right? So 2-butanol, SN1 will be formed. So you should know what type of reagent. It's basically about the substitution and elimination reaction mechanisms. Okay. Moving on to the next question. Which correctly describes the basicity and reducing power of H3PO2, H3PO3 and H3PO4? Okay. Now, what are the options given over there? All three triprotic. Only H3PO2 is a reducing agent. And B option says H3PO2 is a monoprotic and this is diprotic and triprotic. Again, that is monoprotic, strong reducing agent. H3PO3 is a diprotic, moderate reducing agent, and it is not a reducing agent at all. Then option D says that all three reduce silver nitrate, only H3PO4 is triprotic. Okay, this question you are going to answer. I'll give you the idea. Okay, so first understand, if I have an ionizable proton, our ionizable proton means which is attached with a more electronegative atom. Okay, like oxygen. So ionizable proton is there. That is equal to our number of POH bonds. So that decides our acidity, right? Diprotic or triprotic or monoprotic. Okay, and acidity or basicity. And the rule number 2 you need to remember, that is reducing power. Reducing power is always directly proportional to number of pH bonds. Okay, because pH bond can get oxidized, right? So now tell me which is the right answer. Now tell me in the comments which is the right answer. Let's see who says first. Then the next one, neopentyl alcohol reacts with HBr. After protonation and loss of water, a primary carbocation forms. A 1,2 methyl shift then occurs. The carbocation formed after the rearrangement and the final product are. Okay, so let me write CH3, CCH3, CH3, CH2OH. That is neopentyl alcohol reacts with HBr. After protonation and loss of water, a primary carbocation forms. Okay, protonation and OH2 that will leave the compound, so it will form an primary carbocation forms. A 1,2 methyl shift occurs. Yes, methyl shift will happen, which will lead to tertiary carbocation. Sorry, which will lead to from here the methyl group goes there, so this will become positive charge and another will become CH3 group will get joined. Okay, so what are the options given? Methyl butane, it's pentane. Bromo, pentane. Okay, so that will be your right answer. For this complex, del octahedral value that is given in kilojoule per mole. Okay, so now we have to find what is CFSC in kilojoules. Usually CFSC will be asked in the unit of del octahedral. Here they are asking it in kilojoule. How do you go about this question? This is a simple technique, simple rules to follow. But if you don't know, then you can't do this question, right? They just gave you the three, right? Structure is octahedral. So obviously that is T2G3, right? So the CFSC will become, how we'll do 3 into minus 0.4 del octahedral. In EG I don't have any, so 0 into 0.6. So which will be minus 1.2 del octahedral. They have given del octahedral equal to this much. So what we can do, 1.2 into 258, and you will get the answer. Okay. So which is minus 309.6. So if there is a pairing, if different type of questions can be asked from this, if there is a pairing, in the last paper we saw pairing energy value will also be given to calculate the overall value, right? So that type of question also we are expecting this year. Please do check out our last video about the mock test 1 of April attempt. There we have discussed that type of questions. And compound X gives positive to iodoform test and positive to 2,4 DNP test, negative to tolerance test, negative to Lucas test at room temperature. What is that compound X? Okay, so first of all, negative to Lucas test. So which can be that is a test for alcohol, right? And negative to tolerance test, which can be a ketone, and positive to DNP. Positive to DNP means that is having either aldehyde or ketone, right? C double bond O is there. Positive to iodoform, which means there is a methyl group, at least one methyl group attached with a carbonyl. So let's check out the options. Pentanal, 1, 2, 3, 4, 5, pentanal, and pentane 1-ol, 5, 4, and pentanone, 2 pentanone, and 2-methyl butane 2-ol, butane 2 and 2-methyl. So which could be our answer? The first one you see, pentane 2-ol. You can take, let's say, let's start from the first one. Pentanal, that is, will that give positive to iodoform test? Definitely not. That is having only CH2 group over there. So we can easily eliminate that. Then next one is pentane 1-ol. That is also, will that give positive to iodoform test? No. If this becomes the carbonyl group, then I have CH2 over here. So definitely not. And pentane 2-ol, here I have CH3. Okay. Will that give negative to Lucas test? Yes, that is ketone. Yes, negative to tolerance, and positive to iodoform and positive to DNP. So which makes C as your answer. Let's check D also. D I have 2-methyl butane 2-ol, which will give you positive to iodoform test. But what about other test, which will not have any C double bond O group, right? And it will give you positive to Lucas test as well. So which will not be our answer. Next question, identify product AF in the following reaction sequence, starting from toluene. Okay, toluene with KMNO4, that will give you what? Benzoic acid, right? Benzoic acid with SOCl2, that will form benzoyl chloride, that is B. B with ammonia excess, which will lead to the formation of hydrogen will take up the Cl, remaining I'll be having CONH2. Then that is C. With this Br2NaOH, what is this reaction? Which will lead to the formation of amines, amide to amine, right? Then that is our D. D with NaNO2 HCl 0 degrees Celsius, that is diazotation to form C6H5 N2Cl. Then that with H3PO2 F, what is the product? That will form benzene. Okay, so you should know all these reactions to answer this question. A conductant cell with a cell constant of 0.40 contains 0.005 molar acetic acid and gives resistance of 2000 ohm. The value of Ka into 10 to the power 5. What is the nearest integer? Okay. First of all, what you can do, you can find the cell constant value. Okay, cell constant value is given. You can find the conductivity kappa. So kappa, which is equal to cell constant by R, resistance, right? So cell constant, that is 0.40 by resistance, that is 2000, which will give you 2 into 10 to the power minus 4. It is conductivity. After that, I can find molar conductivity, that is kappa into 1000 divided by concentration. Then that does 2 into 10 to the power minus 4 into 1000 divided by, what is the concentration? 0.005. 005, which is 40 Simon centimeter square per mole. After that, you can find delta naught M, which is, here I have acetic acid, right? So acetic acid, lambda naught values are given as H plus is this much and acetate ions are this much. Sometimes they won't be giving the value, they will give you the ions associated with that, so that you have to do this Kohlrausch-Law relationship to find out the answer. Okay, that we can expect. So here we have of H plus, lambda value of H plus lambda naught value of acetate, which will give you 349.8 and 40.9. 349.8 plus 40.9. So which is 390.7. So now we know that they are asking for Ke. So to calculate Ke, I want alpha, dissociation. So alpha, which is equal to lambda m by lambda naught m, that is 40 by 390.7, that is 0.1024. Now calculate Ka. C alpha square by 1 minus alpha 0.005, that is concentration, alpha value 0.1024 square by 1 minus 0.1024, which will comes out to be 5.83 into 10 to the power minus 5. So let's check the Answer, it's approximately 6. So into 10 to the power 5 only they are asking, so approximately 6. Point of glycine. This you can easily calculate using, let me give you the formula. Pi equal to pK1 plus pKa2 divided by 2. So from here you will get Pi value. So how we can, if they are asking for pH, what will you do? Let me know that. Once you find the Pi, what if instead of isoelectric point value, if they are asking for pH of glycine, what will you do? Let me know if you know the answer for this one. Okay. Then the next question, the electrophilic nitration, chlorobenzene gives higher para to ortho product ratio than toluene. Okay. So let's see assertion first. Yes, that is true, because you see for toluene, that will give you 58% of ortho and para product would be 38. So which is the ratio of para ortho ratio would be 0.66. This is ortho and this is para, 0.66. If you take chlorobenzene, that will give you ortho product as 30 and the product as 70. So the ratio becomes 2.33. Okay. So the chlorobenzene gives higher ratio than the toluene. What is the reason? The reason here they have given us the Cl minus group causes greater steric crowding at the ortho positions compared with toluene. Yes, because Cl occupies the ring plane and creates an periplanar interaction, right? Then the CH3. So, and also it is minus injective effect withdrawal specifically depletes the electron density at ortho positions more than the para. That's why its electrophile preferentially goes to para position. That is also true. That's why it is going to electronically, preferred one is para position. So both are true over here. And the next one, the boiling point elevation of 0.1 molar NaCl solution is nearly twice that of 0.1 molar glucose solution. Let's do the calculation for this. And the reason is given as NaCl dissociates almost completely in dilute solution, giving I value is equal to 0, while glucose is a non-electrolyte with an I value 1. Since delta Tb is equal to I kbm, the ratio elevation is 2:1. So let's check. So delta Tb of NaCl, first let's check that one, I kbm. So 2 kb value, that is 0.5, and m value is given as 0.1. So which will give you 0.1024. If you calculate for glucose, then that is 1 into 0.51 into same concentration 0.1, which will lead to 0.0512. Look at the ratio between these two, that is 2, right? Ratio is 2. It's approximately, okay. What the reason is saying, NaCl, okay, non-electrolyte, that is the only difference happening over there, right? Except these two. So which makes both are true statements. Lewis acid strength increases as BF3, BCl3 and BBr3. That is, BF3 is the weakest Lewis acid despite F being the most electronegative halogen. And the reason is in BF3, effective 2p orbital overlap allows the lone pair on F to backdonate into the empty 2p orbital of B, partially satisfying B's electron deficiency. Okay, so let's check the assertion now. The order is true. The Lewis acid strength increases for this, that BF3 becomes weakest Lewis acid. even though I'm having F is the most electronegative halogen. Because F withdraws most electron density and boron becomes Lewis acidic, gives an effective lone pair F2 back donate to the Mg2p orbital of boron, partially satisfying the boron's electron deficiency. That's why as their halogen size increases, the size mismatch with the boron 2p orbital reduces its back bonding, leaving the B progressively more electron deficient and hence a stronger Lewis acid. Yes, so back bonding happens, that will get reduced as the size getting decreases. That is also true. When the dilute H2SO4 is electrolyzed using inert platinum electrode, the pH of the solution gradually decreases. And the overall cell reaction is given, the moles of H plus are unchanged. Okay, so tell me what is the answer to this question. You must be knowing what is the answer by reading this question. Let me know in the comments what is the answer to this one. Then the next one is compound A undergoes two simultaneous first order reactions. A gives B K1 and Ka gives C, K2 values are given. The starting A naught, that is 1.0. Find B into 100 when exactly 50% of the A has decomposed. Okay, so we have to find the value. So what you can do is, first let's calculate K total, which is K1 plus K2, right? That is given as 1.6 into 10 to the power minus 2 plus 6.4 into 10 to the power minus 3, which together 2.24 into 10 to the power minus 2. They have mentioned that is 50% consumption, right? So the difference between A concentration becomes from 1 mole per liter, that becomes 0.5, right? That is the 50%. Now we have to find B concentration. So look at the reaction over here. A gives B at K1 rate, A gives C at K2 rate. We are going to find the concentration of B, but the question says that is a simultaneous reaction. Okay, it's not a step by step, it's a simultaneous reaction. So what does indirectly mean is that we are going to find exactly 50% of A is decomposed, which means the B formed and the C formed, that is 0.50. Together that will be 0.50 because only the 50% is consumed from A. Okay, so how we can go about this is concentration of B by concentration of B plus C in total, how we can find. So which is equal to K1, right? K1 is the rate of first reaction, B formation reaction, by K1 plus K2. Substitute the values over here. That is 1.6 into 10 to the power minus 2 by 2.24 into 10 to the power minus 2. 10 to the power minus 2 will get cancelled out. Remaining will be, what is the value? 0.714. Okay, so that is B by B concentration plus C concentration. What is B concentration plus C concentration? That is the part, that is how much A got consumed, right? So B concentration, which is equal to 1.714 into together how much? 0.5. So which will be 0.3571. So they have asked B concentration into 100. So the answer will become 36. Okay. A conducting cell with a cell constant 0.2 centimeter inverse contains 0.004 molar ammonium hydroxide, gives the resistance this much. This is nearly equal to the question we have solved already. I think you can do it easily. First we have to find the conductivity value and the molar conductivity, that you can solve. Okay. Then the next one, the vapor pressure of the liquid is 100 mm of Hg at 333 Kelvin and 400 mm of Hg at 373 Kelvin. Using Clausius-Capron equation, calculate the enthalpy of vaporization. So, Clausius-Capron equation, what is that? Ln P2 by P1 equal to delta H of vaporization by R into 1 by T1 minus 1 by T2. So let's substitute the values one by one. Pressure, that is 400 by 100, right? And what about delta H of vaporization? So delta H value, let's keep it as such, by R value, that is 8.314, by 1 by T1, that is 333, minus T2, that is 373. So they have given ln 4 value as 1.386, right? So here I will be getting 3.22 into 10 to the power minus 4. So overall, delta H of vaporization will become 1.386 into 8.314 divided by 3.22 into 10 to the power minus 4, that is 35,776. So approximately that becomes 35.8. They are asking it as, okay, so 36 again. Okay, then a 0.3 molar solution of acetic acid in benzene shows delta TB value this much, Kb value is given. What is the degree of association? Okay, so first of all, I value you can calculate it by, we know that delta TB is equal to I Kb m. So del I is equal to delta TB by Kb into m, right? So delta TB is given as 0.507 by Kb value is 2.53 and 0.3 molar solution. So which will give you the I value as 0.66. Okay, so what I said, acetic acid dimerizes, right? So as a next step, how I is related to alpha now. For this kind of dimerization, what will happen? The total moles, 2A gives A2, right? So the total moles will become, this will become 1 minus alpha and that will be alpha by 2, right? That is our total mole. So overall that will be 1 minus alpha by 2. So I, which is equal to 1 minus alpha by 2, that is equal to 0.66. That's what we found from the first step. So now find out alpha from here. So if you do the calculation, you'll be ended up with the alpha value as 0.66. Because they are asking alpha into 100. So which will be 66. Next question is 0.535 grams of primary amine or NH2 is reacted with excess of acetic anhydride. Okay. Then after reaction, the mixture is hydrolyzed and titrated with 0.5 molar NaOH. Okay. I have NaOH solution. Blank without any reaction. Only anhydride, that is hydrolyzed, means 40 ml of NaOH is consumed. After the reaction with amine and hydrolyzation followed by, then it requires 30 ml of NaOH. Okay, using this data, we are going to find the molar mass of amine. Okay, so one thing we have to understand here, it involves two reactions. First one is acetic anhydride. What is the structure? CH3, C double bond O, O, C double bond O, CH3, right? Which upon hydrolysis, what that will give 2 moles of acetic acid, right? That is the first reaction you must know. And the second reaction is that with acetic anhydride, I'm writing it here itself, RNH2, what will be the reaction? It will form RNH COCH3 plus acetic acid. So what is the difference between these two forms is that from one anhydrate, 2 acetic acids are formed in case of hydrolysis only. Okay, with the reaction with amine, I got 1 acetic acid. Okay, that is the main difference that you have to understand about this question. This is a simple back titration question only, but you have to understand this thing very minutely. Okay, so 1 anhydrate gives 2 acetic acid, which requires more amount of NaOH to neutralize, right? That is what the first reaction here. And the second one, that is having only 1 acetic acid, that requires less amount of NaOH than the first one. Okay, the question is clear now. Now we are moving on to the answer part. First, let's calculate the first thing, blank, which requires 40 ml of NaOH. So in blank, that is 40 ml of NaOH. NaOH concentration is given as 0.5 molar, right? So the number of moles, that is equal to molarity into volume, that is 0.5, volume that is 40 ml. So convert that to liters, you will get 0.04, right? So which will be 0.02 moles. Okay, that is the consumption of NaOH in the blank. So how much anhydrate must be consumed over there? Number of anhydrate in the first reaction, first step, that is half of it, because anhydrates consist of 2 acetic acid. So which is 0.01. Okay, this is clear. Now the second one is titration. Titration with the reaction, after the reaction. So for that, I have this sample that requires 30 ml of NaOH, right? Now again, the number of moles of NaOH consumed, that is 0.5 into 0.03, that will become 0.0025. No, wait, 15. It should become 0.015, right? That many moles of NaOH was consumed. Now consumption is from acetic acid. Acetic acid which is formed from 1 hydrate, 1 acetic acid. That is the ratio. So the anhydrate reacted also 1 here. So what would be the remaining anhydrate? So the anhydrate remaining, number of moles remaining, that would be half of it, right? Which is 0.0075 moles. Is it clear? Acetic acid moles is this much, anhydrate remaining, that would be this much. Okay, now anhydrate consumed by the amine, number of moles of consumed, that is, I had 0. This much is remaining. I had in the first one, I had 0.01. 0.01 minus 0.0075, which is equal to 0.0025 moles, right? That much is consumed in the second part after the reaction. Again, the number of moles of amine, that is equal to number of moles of anhydrate, that is equal to number of moles of acetic acid formed. That is in the same ratio, I mean. Okay, so which I can take it as number of moles of amine is equal to 0.025, right? So this much moles of amine means what is the mass? That is simple, right? Because they have given the given weight 0.535. So molecular mass, which is equal to mass by moles, that is equal to 0.535 divided by 0.0025, that is 214 gram per mole. Okay, so that is your answer, 214 gram per mole. So keep on working more and more questions. Let me know what else you want. Let's see in the next session.